We used to believe that our world and galaxy was infinite and would never end. Once we started to examine the universe, we soon came to realize that that idea was not true. Scientists started to come up with theories and ideas that came to explain that the universe, all matter, and energy in space, in fact, had a beginning and will have an end. The universe started in a small, hot, dense state that quickly expanded with an eruption of light and energy that we call the Big Bang. After the rapid expansion of heat, the universe cooled down and started to form the stars and planets that would make up our solar system we know today. It's interesting that the Big Bang made everything work out perfectly. For example, if the Earth were any closer or farther away from the Sun, it would drastically change our way of life, or make life not even possible. Our tilt of 23.5 degrees is the perfect degree that creates the seasons and for life to live year-round. Even the speed at which our Earth rotates is just as perfect as the tilt. One rotation is equal to 24 hours or 1 day. Our Earth is 360 degrees around, leading to 15 degrees is an hour with the way we describe time. Even the moon and its distance from the Earth is perfect. If the moon was non-existent, our world would struggle without it. The moon not only provides light for us, but affects the water on our Earth. It affects the tides and oceans. It also affects the world's crust by heating it and causing the loss of energy, and stabilizes the axis of rotation of the Earth. To observe our universe, the observable objects must be also measured. Over the years, humans have come up with ways to measure things like time, length, and mass. In our universe, everything is in motion. People are walking or running, driving cars on the street. Even things that we don't see are still moving. The Earth is constantly revolving around the Sun. The stars are moving at high speeds, and the Sun is revolving around the center of the galaxy. Motion is present in any change that matter goes through. Isaac Newton came up with 3 laws of motion that accurately describe how things move in the universe. Newton's first law states that an object will remain at rest or in uniform motion in a straight line unless acted on by an external unbalanced force. So if there is no force acting upon an object, that object will stay at constant velocity. There are many examples of velocity: gravity, friction, buoyancy, tension, and some examples that we see in our world. Newton's second law of motion explains how an object's velocity changes when an external force is acting upon it. The equation F equals ma describes the change in velocity. His third law states for every action there's an equal and opposite reaction. So think, when you're driving down the highway at 11 kilometers an hour and a butterfly hits our windshield, it's hard to think of that butterfly having any impact to the car at all. Oddly enough, the butterfly exerts the same amount of force on the car as the car did on the butterfly. The only difference is the damage done to the car can be washed away with the car wash. Physics can explain everything that is going on in our world, even something as simple as making a cup of tea. Heat is energy that is transferred from hot to cold objects, so the burner on the gas stove transfers heat to the teapot. The air around the teapot is also warm due to radiation. The transfer of heat energy due to electromagnetic waves. Temperature is mass out of hotness or coldness. Tea is usually too hot to drink right after the water boils. It could be at least 100 degrees Celsius. Convection cooling helps make it bearable. As the tea sits and cools off due to the circulation and movement of molecules, the spoon used to stir the tea gets hotter after stirring. And it is an example of conduction. Waves are all around us in life, even in places that we wouldn't expect them to be. Waves on the shoreline of oceans is a place that we'd expect waves. When the waves ripple, the water is a transverse wave, one where the particle in motion and wave velocity are perpendicular to each other and are very easily seen. Light and sound are some not so obvious examples of waves. Light is a transverse electromagnetic wave, and color is light. Objects don't have color, but instead give off a light that appears to be a color. Different colors are determined by different wave frequencies. Sound can be transmitted as both a longitudinal wave and transverse wave. The pitch of a sound is related to the frequency of the sound wave. The higher the frequency, the higher the pitch. The Doppler effect explains sound waves. Like, for example, a siren on a fire truck. As the vehicle comes towards a person will hear the sound get louder and louder. But as the vehicle passes and then starts to go away, the sound will start to decrease. This is because the movement of the vehicle coming towards and passing the person causes a shift in observed wave frequency. Everything that we have gone over is made up of atoms according to Dalton's atomic theory. Every time we breathe, we are inhaling atoms. When we drink water, we are ingesting atoms. When we write, we are using a pencil made of atoms. Even our bodies are made up of atoms. Thanks to the evolution of the atom and the discoveries from the scientists, we now know that the atom has a nucleus which contains protons and neutrons, also called nucleons, Orbiting the nucleus are electrons, which are negatively charged particles. Protons are positively charged particles, and neutrons are neutral. We have been taught that like charges repel one another, but protons and neutrons are held together somehow in the atom's nucleus. What holds together protons and neutrons is quite an interesting force, the strong nuclear force. Outside of this very short range, the force is non-existent and binds the protons and neutrons together. This force is the very thing that holds together everything in our world at the nuclear level. Although everything in our universe is made up of atoms which are rarely by themselves, almost everything that we interact with and see are possible because of chemical bonds of the elements on the periodic table. These elements are like the ingredients to countless recipes to make up our world. Elements are found everywhere. We can find them in our water, table salt, and in rocks and minerals. There are many reasons on why geology is so important to life and civilization. Earthquakes, landslides, floods, droughts, volcanic activity, ocean water currents, minerals like gold and silver are just a few examples. Many of Earth's natural disasters and much of the way the Earth was formed has been explained through the help of geology. There are things like fossils as movements. We can discover what our world was like millions of years ago. We now know that we were once all a big landmass called Pangaea, and our countries came to be due to the continental drift. It also explains how water can break rock. Sometimes that seems far from possible. Science affects us all every day of the year, from once we wake up, all day through the night.